This video will walk through developing the sales and operations planning model that is a tool that a company can use in the medium term, like 12 months, to determine its production schedule, as well as its workforce and hiring plan. So we have a lot of different assumptions in here. Some are operational assumptions. A lot of them are regarding the usage and the cost of our labor, and these will be used to develop the model. The biggest assumption that's missing on the top line is a demand forecast for the product. So we're going to be using a demand forecast that was developed for product A in a previous chapter of the textbook, and it's over here on the tab Product A, and it was a seasonalized version of a trend-adjusted exponential smoothing forecast for this product. And so we can see out here with the black line the forecast for the next 12 months. And it's those 12 months that we're going to be planning for. So right here we have the forecast for the next 12 months that was developed with this model. We need to bring this forecast into the top line of the sales and operations planning model. We'll do that with an index function, and we'll round to the nearest unit. So we're going to round and then use the function called index, and we'll click over onto the product A forecast and highlight the forecast for the next 12 months. We'll use absolute references on the row and column. Now I'm going to type a comma and then click back over. And so in this column for month 1, I want to reference the first value in that forecast. And so I don't necessarily need the tab name, but I'm going to use a function, column B1, and then -1, because the column for B1 is 2, and if we subtract 1, then we have 1, and then that will bring in from the reference on the forecast the first month. When we copy this across, it'll bring in the second month, and so on. There's only one column in the index range, so I'll just do (1) for the column. And then (0) will round, that's the outer function, to 0 decimals. So our forecast for month 1 is 2841, and we can see over here where the 2841 came from. And we'll copy that across. All right, so we have the forecast, the demand forecast for all 12 months. Down here we have the decision variables, which will ultimately be the changing cells. And so they're highlighted in yellow. And so these are merely starting values that we'll use and allow Solver to change those as changing cells. So right now, these are just starting values, and those will certainly change. But we'll have some values in there when we build the workforce and capacity model. Okay, so where do we start this in month 1? Well, up here at the top, there's an assumption that the company has 40 workers at the beginning of month 1. So we'll bring that down here to the workforce and capacity model. All right, and so the available workers, in any month, we can choose to hire workers or fire workers. And so the available workers is going to be the beginning workers, plus the workers hired, and minus the workers fired. The regular labor hours worked. Well, what we have up here is an assumption that every employee works 160 regular hours per month. And so we'll multiply the available workers times the regular hours worked. All right, now we have an assumption in this model that's called utilization. And utilization represents the fact that workers are not always productively working 100% of the time that we're paying them. They might be doing tasks like cleaning, they might be doing training, they might be on vacation or taking breaks. And so This company assumes that of the time we pay employees, 80% of that time is spent productively working on projects or working on production. So we need to multiply the regular labor hours worked times the utilization, and that gives us the hours that are actually available for production. Now, this model allows for the potential of working overtime. And so we have an assumption up here that says the maximum overtime per worker per month is 10 hours. And so if we have 45 workers, then they can each potentially work 10 hours. That'll give us the maximum overtime hours that we could assign in a given month. So this means that the combination of overtime and regular labor hours available is the total hours available for production. Now, we've got to be careful. This is the maximum hours we could assign, but it's going to be a decision how many we actually do assign in a given month. So the total labor hours available are the overtime hours assigned plus the regular labor hours available. Now, a major assumption in this model is the production capacity, and that's affected by the labor productivity. So up here we have an assumption that says in each hour that one worker works, they can produce approximately 0.43 units per hour. And that would be based likely on a historical data that, perhaps in a past month or year shows the number of units we produced and then the number of labor hours people worked, and we could estimate this labor productivity. And an example's in the textbook. So we would multiply then the labor hours available times the labor productivity. Now, the excess capacity would be the production capacity minus the units produced. Now, right now, this is when we hit enter, this is going to get a negative number, which will have a constraint that won't allow that ultimately when we solve the problem. All right, so for month 2 and beyond, what we'll do is carry the available workers over from the previous month, except that we have a worker retention assumption in this model. And so month to month, we assume that we're able to retain 90% of our workers. So when we bring forward the available workers, we multiply it by the retention assumption. Now, the rest of the formulas for month 1 can be copied over to month 2. And then we can copy these the rest of the way across. And so that's our workforce and capacity model. Now we'll build also the production and inventory model, and it'll work like this. There's an assumption for beginning inventory in this model. And right now it's up here on line 7, and it says we currently have 100 units available. So then what happens is that we can add the beginning inventory plus the units produced, and that would give us the total units available to meet demand. And then our ending inventory then is the total units available to meet demand minus our demand, which is way up on line 2. And we got that demand from our forecast. Now, in month 2, for our beginning inventory, we want to carry our ending inventory over to month 2. And we want to copy these other over. And then we'll copy everything over to month 12. So that gives us our production and inventory model.